You want to start a development with the DAC EV12DD700. You want to take advantage of its 2 channels capable of generating signals from low frequency to Ka-band in multiband and simultaneously. You want to benefit of its digital features, enabling unprecedented level of dynamic RF system reconfiguration on the fly, whether for SAR imaging, space transmitter, telemetry or EW. An FMC Plus board compatible with commercial on-the-shelf FPGA development boards and FPGA design examples are now available to accelerate your development. Here you can see an overview of the EV12DD700-FMC Plus evaluation board, giving access to the 2 DAC RF outputs using a double-width FMC Plus standard connectors interface. In this video, I will give you all the information you need to get started with the EV12DD700-FMC Plus board and your FPGA using the evaluation kit from Alpha Data embedding a Kintex UltraScale KU060. First, we will see all the steps to create Vivado project, generate the bitstream and load it in the FPGA. Then, using the graphical user interface, I will demonstrate how to generate a signal in Ka-band. Now, let's start by generating FPGA project using Vivado. This project uses Vivado version 2019.2. Open Vivado, click on Tools, run Tickle Script, and go into the design example directory to select the Tickle script and click OK. Then wait for the end of the project generation. Once processing is complete, the project closes. Click on Recent Project View to open it. You can now generate the bitstream. It takes approximately half an hour to complete. A test bench is also available here to simulate the EasyStream serial interface used to transmit samples between the FPGA and the DAC. After the bitstream generation, we are ready to load it in the FPGA. But before, you have to power on the FPGA board and to connect the JTAG cable. Then, in Vivado, open the Hardware Manager. Click on Open Target Auto Connect. Then right-click on the FPGA reference and click on Program Device. Look for the bitstream file and click on Program. With this bitstream, we will be able to load the pattern in the FPGA memory and then to transmit pattern samples to the DAC using the EasyStream high-speed serial interface. Now we have programmed the FPGA, we can power on the DAC board using the switch on the power supply board. Before launching the graphical user interface, let's take a quick look to the hardware setup. Here you can see the FPGA board and here the DAC board. They are connected together using the FMC Plus interface. We also use a signal generator to generate the DAC input clock and the spectrum analyzer to monitor directly the DAC channel B RF output. There is only here a balloon to convert the differential output to the spectrum analyzer single-ended input. So now, let's launch the graphical user interface provided with the DAC board. The DAC on this board is an 8-bit part only, so I must select 8 bits. Then, to reach Ka-band, I have to select 2 RF mode and to set the DAC input clock, for instance, to 18 GHz to get a sampling frequency at 9 gigasample per second. Then, I must enable the FPGA transmitter clock reference. The SSO clock is generated by the DAC. Finally, after synchronizing the DAC serial interface, we are ready to generate a signal using the pattern generator. I will start with a frequency at 18.9 GHz. And so, you can see that this DAC is capable to generate a signal in Ka band with an SFDR of 50 dBc. Now I set the DAC output frequency to 22 GHz and we have an SFDR of 45 dBc at the end of the fifth Nyquist zone. This brings us to the end of this video. You have learned how to get started with the DAC EV12DD700 and a Kintex Ultrascale FPGA. And so, you can see how this will help you to gain precious time in your development. Plus, the design example and the EasyStream interface are license-free and open source, so you can modify them as necessary. If you have questions, or if you are interested either on the DAC FMC Plus board or in the FPGA design example, please contact us using Teledyne E2V hotline email address. Thanks for watching.